Hello, my kiddos and kiddas. We are looking at ellipses today. So the way I describe it, at least this may not be the most official definition, is definitely not the most official definition, is a taller, wider version of a circle. So you could say it's like an oval. Instead of having a diameter that goes straight across, and the diameter is the same no matter where you are in the circle, as long as you're going through the center, the ellipse has a major and minor axis. So because one part, it's not even the entire way around, we have a shorter version and a longer version, then we have a major and minor axis. So the minor axis is going to be the shortest distance between 2 points on that ellipse that goes through the center, and the major is going to be the longest. So here we can see the major axis that goes through -3 to +3 on the x-axis, and then we have our minor axes that goes through the 2 and -2 along the y-axis. So these distances that, just like the circle has a radius, these have a type of radius. So our longest one we typically label with A. So that's the distance from the center to the edge, the same way a radius would work. And then from the center to the edge, the shortest distance, we would label B. And so again, that's very much similar to a radius. When we're doing these, that A and B come from this equation. Here, the A, I like to think of it as alpha, the big dog. It's always going to be the larger number. So we know if this is going to be a taller ellipse, if the larger number is underneath the Y, we know it's going to be a wider ellipse if that larger number is underneath the X. And just like with our circle, we have our H and our K that tell us the point at which our center is. So whatever value is with your is with your X, that's going to be the X value of your center. Whatever value or number is with your Y in those parentheses, that's going to be the Y value of your center. And whatever is found underneath each of those values, so whatever A or B is, no matter which is larger, whatever is coming from underneath the X value, when we take the square root of that, that is how we are going to move along the X. Same with whatever is underneath the Y is how we're going to move along the Y value. So here, because our largest number is underneath our X, we would move from our center left and right, whatever that value of A is. Because the A is underneath our Y value for the vertical ellipse, that means that we are moving up and down that value of A from the center. So we're adding and subtracting A from our center. And so B is going to be whatever the smaller value is, and that tells you the length of that shorter distance that kind of acts as a radius. And so whatever it is underneath, that is how you move from the center. So because the B is found underneath the Y value when we have horizontal ellipses, then we are going to be going up and down that value of B, so adding and subtracting B to our center. And then if it's underneath our X like it is in the vertical, then we would be adding and subtracting to our X value of our center, meaning we're going left and right from our center, that value. So here for our first one, we have the ellipses drawn, and we want to plug these into the equation that was found. First things that I like to work with is my center, so my H and my K, but I do have all of these values that I'm trying to figure out. So because I have a wider ellipse here, I know this is going to be the horizontal, so I'm looking at this first equation. And so I like to find the H and the K first. And here my center is going to be 0, 0. That's in the very middle of my ellipse. You could also say, okay, this is the major axes, this is the minor, so where are those two intersecting? So because I am here at the origin, then my H and K are both going to be 0. Also for this, I need an A and a B. I need to figure out what this A value is, and I need to figure out what this B value is. Because A is underneath the X, that means it's the distance from my center to the edge. So it's like the larger radius, if you will. And so here, if I go from the center, which is 0, 0, over to 3, 0, that means this is a distance of 3. So my A value is 3. And then for my B value, the shorter, I've gone from the center up 2, so my B value is going to be 2. And then I can just plug everything in. So I'll have X minus H, which we said was 0. We don't have to have minus 0 there. You could just say X. And then I went left and right 3. because I was moving along my x-axis, I'm going to put that 3 underneath my x. Remember, that's always going to be squared. That's a part of our formula. And then plus y minus my k value was 0. Again, you don't have to write minus 0. You could just say y squared. That's totally fine. And we went up and down 2. So along my y-axis, we went 2 spaces. So I'm going to have that 2 underneath my y. And this is always going to be equal to 1. So if you wanted to, you could simplify this. This is a perfectly fine answer. I think it's great because you can see there's no question as to what each of the values are, but oftentimes you'll see this a bit simplified to where we would have x squared over 9, so that 3 squared, plus y squared over 4 equal to 1. So this is the most common way that one would show their answer, completely simplified out. Next bit that I'm going to go over, they've given me the vertices and the co-vertices of my ellipse. So when they talk about the vertices and co-vertices, the vertices are going to be those endpoints that are along the major axes. So the farthest that we've gone around the center or from the center, and our co-vertices are going to be the points on the ellipse that have the shortest distance that still goes through that center. So I'm a very visual person and I tend to want to sketch this kind of stuff out. Here we have my vertices at 0, 6, and 0, -6. So that means we're along the y-axis. So we'd have 0, 6, and 0, -6. And then our co-vertices are at 5, -5, and these are both comma 0. So that means we're along our x-axis. And I'm going to roughly sketch out my ellipse. Here I went up and down 6 from my center, and here I would have gone left and right 5 from my center. We can see that because these zeros are the same for our x and these zeros are same for the y's, that means our center has to be at 0, 0. You could always think, what is the midpoint between 6 and -6? The midpoint would be 0. Same with -5 and +5. Your midpoint is going to be 0. So that means my h and k are going to be 0. In order to go from the center to our vertices, that means I would have gone a measurement of 6. So from 0 to 6, we would have had 6. From 0 to 5, I would have gone 5 units. So alpha in this case, the largest one, is going to be 6. The b in this case is going to be 5 as a shorter. I can start plugging these in. So I have x minus my h we said was 0, quantity squared. And when I went left and right from my center, that was the 5 units. So we went from our center to the 5, 0, we went left 5 and right 5. So that means my 5 needs to go underneath my x this time. My k value is also 0. And we had gone up and down 6 in order to get those vertices. So this is going to go underneath my y value. Last thing I need to do is simplify. And we're done. So the last thing I'm going to do is this one graphing, and the rest of these I'm going to save for my students. So the first thing they want us to do is find the center, the length of the major and minor axes, and then put everything onto the graph. So again, our center you can always find from our h and k, whatever is adding and subtracting inside with our x and y values. So here I have a -3 inside with my x, which means my h is going to be 3. Remember, it's always x minus h and y minus k. So because it's minus, we're going to keep that 3 as positive. And then in order to get a +4, we would have had to do minus -4. So my k is -4, meaning I have a center at 3, -4. Underneath my a value, we have a 16. Or sorry, underneath my x, we have a 16. So that means I'm taking the square root of 16 in order to figure out the distance from my center to the edge. We're going left and right 4 units. Underneath my y value, we have 4, which means from our center, take the square root of 4, and we'll be going up and down 2 spaces. So then on here, I'm going to start graphing. I tend to like to do the major and minor axes at the end. You could do it now. So my major is going to be what goes the longest. So if I'm going left 4 and right 4 from the center, then that entire line is going to be a measurement of 8. And if I'm going up 2 and down 2 from the center, then that entire measurement is going to be 4. I'm going to start with graphing my center. So +3, -4. Said we were going left and right 4. We found that 16 underneath our x. And we're going up and down 2 from our center. And then I'm going to draw my ellipses through all of these points, all 4 of them. And I'm not going to judge on the artisticness or the perfection of anyone's ellipse. Just please don't make it straight lines in between here. It's not a diamond. It is an ellipse. Should have some curves. If it doesn't have curves, we're going to have some issues. And so there's my nice little ellipse. Kind of looks like an egg. Anyway, so if you found this helpful, then that is super awesome. Please like and subscribe. And if you think that this could be helpful for someone else, then please feel free to share it. Spread the love.